Here we are, lesson 5.6. We're going to be graphing some linear inequalities. We're first going to check some solutions, then we're going to learn to graph. So when we're talking about a linear inequality, remember there is no equal sign. These are not necessarily called equations, even though they're very similar to equations. They have a less than or equal to, a greater than, or a greater than or equal to. Remember when we're checking these, we need to check the ordered pair and see if it makes the inequality true. So I'm going to skip this and go right here. So I'll do number 1. So x plus y is greater than 5. That's the ordered pair is 3, 2. So x and y, I'm going to substitute those in. Is 3 plus 2 greater than 5? So when I solve over here, I get 5 is greater than 5. At this point, I'm asking myself the question, is that a true statement? And it is not a true statement. So no, this is not a solution to this system. 5 is equal to 5, but it is not greater than. We would have to have a different symbol, like a greater than or equal to or less than or equal to, in order for that to be true. So go ahead and try number 2. Pause the video and try number 2 now. Number 3, I'm going to substitute in. So -1 plus 2 times 2 must be less than or equal to 4. -1 plus 4 less than or equal to 4 is 3 less than or equal to 4 at this point. Is this a true statement? Yes, 3 is less than 4. So yes, this ordered pair is a solution to that inequality. All right, now graphing. This is where it gets a little tricky. So the graph of a linear inequality in 2 variables shows all the solutions of the inequality in a coordinate plane. So we used to graph just on the number line. Now we're going to graph in the coordinate plane. So we graph the inequality as if it were the equation, okay? So it says all solutions of y is less than 2x lie on one side of the boundary line, which is y is equal to 2x. Now you may notice that this is a dashed line. This is kind of over here. A dashed boundary line means that the points on the line are not solutions. A solid boundary line means that the points are solutions. So what does this look like? So remember when we were graphing inequalities on a number line and we had an open circle, right? And it would go left or right. Well, now we're going to replace that knowledge when we're graphing the line with a dashed line, okay? What this means is that it is either less than or greater than. Also, when we graphed on a number line, we sometimes graphed it with a solid circle. That meant that it was part of the solution set, and then we, drew the line left or right. Now, we will show that boundary line as a solid line, okay? So all the points on that are included in the solution, and this represents situations in which you have less than or equal to or greater than or equal to. So a lot of things to remember. The boundary line is dividing the coordinate plane into 2 half planes. Notice that we left one of them unshaded, the one that is shaded. So in order to determine what is shaded, you want to test the ordered pair 0, 0. So 0 less than or equal to 2 times 0, 0 less than or equal to 0. Yes, it is a solution. Therefore, it should be shaded below that, right? And also this does say, less than. So remember that the y going down is less and the x going to the left. So if we ever have a vertical line going to the left, then if we were to go above, y gets bigger or is greater than in the up direction. So a little bit of it is directional and a little bit of it is testing a point. All right. So when they graph this, they're first going to graph it. This is missing an equal sign here, but this is right out of your book. First, they're going to graph the line y is equal to 2. They're going to use a solid line because of the less than or equal to symbol. And then you can test the point 0, 0. If the point 0, 0 is true, then it has to be included in the shaded part. If it is not true, then it is not included in the shaded part. So let's give this a try. So we have y is less than 4. So we want to find 4. And now we're going to, we have a line on this. It's horizontal. And this tells us it's a dashed line. So we want to make a dashed line as neatly as we can through these points. Okay. Now we test the point 0, 0. Is 0 less than 4. Yes, since this point is less than 4, right? All the points below the bottom part of the plane gets shaded. Go ahead and pause the video and try number 8, and I will try number 10. For number 10, we are graphing a vertical line, and we have x is less than or equal to -1. So again, we have, the x coordinate is always -1, which makes a vertical line, and it's going to be solid because of the less than or equal to symbol. Now, if I test 0, 0, is for the x coordinate, is the x coordinate 0 less than or equal to -1? It is not. So since it is not, that part of the plane is open, right? Also, it kind of makes a little bit of sense that all the values of x to the left would be less than. So that's another way you can kind of understand or comprehend. All right. Here's one where first we have to put it in slope-intercept form, graph the line just like you would if it were an equation, remembering the dashed or the solid line based on the symbol, and then checking the point 0, 0. So let's give this a try. So first, I'm going to treat it like an equation. So I have the order, the y-intercept is the +1. My slope is 3, so I would go up 3 and over 1. Right? Likewise, I could go down 3 and back 1. Now, it's going to be a dashed line because of this symbol. So I do my best to make the dashed line go through the points. Now I have to determine which ones are, it's going to be shaded in. Now, my instinct is that y is less than, and if I'm at this point or if I'm at that point, y decreases down here, right? Decreases down here. But let's test out the 0, 0. Is 0 less than 3 times 0 plus 1? Is 0 less than 1? Yes, it checks out. So that means this point, 0, 0 would be shaded, and that's how I know that I can shade to the right of the plane. Okay, so go ahead and try number 14 to graph number 14 and determine what side of the plane is shaded. Okay, so number 15, I'm going to, all right, so I'm going to rewrite this. It's less than -x plus 2. Then I'm going to, but remember this is a -y. So then I have to divide everything by -1. So I'll get y. Now remember, when you're dividing by a negative, you reverse the symbol. We're reversing the symbol here, and we'll get a positive x minus 2. So in that case, I'm going to graph it like it's an equation. Okay, I'm going to graph the y-intercept, and then I'm going to go up 1, up 1 over 1, up 1 over 1, and down 1, back 1, and so forth. And then I have a dashed line. Okay. All right. Now, y is going to be greater than this. So I want to test out 0, 0. Is 0 greater than 0 minus 2? Is 0 greater than -2? Yes, it is. So that means that the point 0, 0 is shaded. So I know that it's all of this part of the plane that is going to be shaded. Okay? All right, last equation. The online store sells digital cameras and cell phones. The store makes a $100 profit on the sale of each camera, which is the X, and 50 for the cell phone. So I have 100X plus 50Y, and then we want a profit of at least 300. So can I exceed 300? Absolutely, I can. So we could, put it in slope-intercept form, or we could actually solve for the intercepts because I have an x and a y intercept here. So I'm going to solve for the intercepts on this, right? These two equations need to be solved so that I know where it's crossing the y or the x axis. Here I'm dividing by 100, and I'll get the x is going to be at 3, and here I'm dividing by 50, and I'm going to get the y is greater than or equal to 6. So that means I have a point here, and I have a point here. And then because it's greater than or equal to, I know that I can draw a straight line, right? And these are like a finite set right here, okay? Because we're talking about a real life application, we do not have negatives don't have the any application or any meaning in this problem. But we want to know what other combinations could solve this, and we know that it can be greater than or equal to 300. So in the greater than, right, would be, so is 0, 0 a solution? Is 0 plus 0 greater than or equal to 300? No, it is not. So that means that 0, 0 is not shaded. That means this side of the graph is shaded. Then they want me to come up with two other possible combinations. Well, that could be anything, right? I could be over here. I could be, at this point and say that I had 5 cameras and 1 phone, right? I could be way over here and I could say that's 9 cameras and 8 phones. So you just pull out other points that would possibly also satisfy this situation. And that concludes the video.